Geometry review for test 3, lessons 1 through 15, part 2. We're going to start off with this class with question number 6. Question number 6 on their sheet says, if a regular triangle, what do we know about regular polygons, period? We should know two things. They have equal sides and equal angles, like they're equiangular and equilateral. Okay, so it's going to look like this, right? If it says a regular triangle has a perimeter of 15x plus 27. All right, so, this side, whatever it is, plus this side, whatever it is, plus this side, whatever it is, comes out to a total of 15x plus 27. We want to know what is the length of just one side. Well, let's say we knew all of this was 30, right? The perimeter equaled 30. What would we do to find the length of just one side? Divide by 3, and we would know that the side length, right, was just 10. Side equals 10. Should we do anything different with this? No, do the same thing. So I'm going to divide by 3. What's 15x divided by 3? 5x. And what's 27 divided by 3? 9. So the length of each side is 5x plus 9. Does that make sense? But we have to know something about regular polygons in order to set that up. Okay? All right. After 6 was 15, right? Okay, 15. Okay, 15. All right, gives me a picture here of a triangle. Looks like an obtuse triangle. We'll work with it. Something like this. Okay, I'm going to add some color to it just so we can distinguish some things. We got 11 centimeters. We got 5 centimeters. We know that this line right here is 8 centimeters. We got 18 centimeters. Okay, we can label our parts A, B, and C. And our question is that we want to determine the area and the perimeter. Okay, well, perimeter should be easy. Do I know the lengths of all 3 sides of my triangle? Yeah, right, I've got 11 plus 8. Let's see, so that's giving me 19 plus 18. So I should get 37 centimeters, right? Perimeter equals 37 centimeters. Any trouble with that? Okay, but with my area, I need to know my base and my height. What is the base of this triangle? All right, my base is 11. Can anybody tell me what the height is? 5, right? Because it's the perpendicular distance from a vertex to the side opposite of it. So this red line is representing the height of the triangle, not the 8. Okay? So if you used 8 there, that would make it wrong. Okay? All right, so we're going to multiply those things and divide by 2. 11 times 5 is 55. 55 divided by 2, 27.5. So 27.5 centimeters squared. Okay, so be ready for that. Let's see, after that was number 17. Number 17 wants us to find a counterexample. Counterexample meets the hypothesis, but does not match the conclusion or proves that the conclusion is false. So it says find a counterexample to this conjecture if a quadrilateral has 2 pairs of congruent sides. And I think I actually did answer this question with that class, but I'll answer it again. We want a quadrilateral, so we want a polygon that has 4 sides and has 2 pairs of sides that are congruent, but is not a parallelogram. Okay, so we have essentially 2 options. Okay. A rectangle is a parallelogram. A square is a parallelogram. A rhombus is a parallelogram. Name another quadrilateral for me. A square is a parallelogram. Okay, we want something that has four sides but is not a parallelogram. Huh? A trapezoid. Okay, so now as we found a four-sided figure that is not a parallelogram, but we have to see if it is going to be a if it has two pairs of congruent sides, right? Right. This side can be congruent to this side, but are the other two sides going to be congruent? No. And it won't work out here either. So a trapezoid is not a counterexample because although it is a four-sided figure, it doesn't have two pairs of opposite sides that are congruent. So it doesn't meet the hypothesis. Okay? What else do we have? Something that's not a trapezoid, not a square, not a rectangle, and not a rhombus. A kite. Very good. All right, a kite, okay, by definition has two pairs of congruent sides, but it is not a parallelogram. It's got four sides, okay, so kite is my answer here. Okay, does that make sense? All right, so you have to know some things about our quadrilaterals, how to classify them, and what their characteristics are. All right, 18. Find a counterexample to this conjecture. Apples are red. I need a counterexample. Green apples. It kind of messes me up writing green with the color blue. Okay, green apples. Green apples are a counterexample. You need something that is an apple, but is not green. Okay? All right. So that's 18. Let's look at 19. 19. Determine whether polygon JKLMN is convex or concave and explain. I'm going to try to do my best to draw it if I can. Something that's a little bit like this. Not too far off, and I think it'll still match what they're going for. Is this convex or concave? Convex. How do we know? We check the diagonals, right? Is that diagonal inside or outside the polygon? Inside. Let's draw another diagonal. Is that diagonal inside or outside the polygon? Inside. I can't draw any more diagonals to that point, so let's try there to there. Inside or outside? Inside. Inside or outside? Inside, okay. Let's see, we could be able to go there, inside or outside. And I don't know that I can draw any more diagonals that I'm aware of. Are all those diagonals inside? All right, so my explanation, yeah, it does. I'm really good that way. But my explanation is that all the diagonals of the polygon occur inside the polygon. Okay? If at any point a diagonal from one point to another point reaches outside the polygon, it is a concave polygon. Okay? Do we understand that? Great. 11. 11. Prove the lines A and B are parallel. Okay, so it gives me something that looks like this. 135 and 135. Okay, this is where it's another lesson 12 deal. Remember how I told you whenever we were covering lesson 12, this is important, you need to know this. This is going to keep showing up. All right, we're going to use this over and over and over again. All right, and it seemed really simple at the time. Can anybody tell me those two angles, we understand, what do we know about those two angles that have degree measures? They're exterior, yes. They're alternate exterior. Okay, so they're alternate exterior angles. What else do we see about them? They're congruent. All right, so how can I tell that lines A and B are parallel? What theorem would I use? Well, you gave me probably 2/3 of the words needed. You said that they were exterior. You told me that they were alternate. How? You're close. You're missing one word. Converse. Converse of the alternate exterior angles theorem. Okay? And I would accept that answer. They might want something along the lines of, you know, if two lines are cut by a transversal and their alternate exterior angles are congruent, then the two lines are parallel. Let me look at their answer on number 11. The lines are parallel by the converse of the alternate exterior angles theorem. I would accept that right there. Okay? Does that make sense? We're good to go. All right, last question that has been asked of me, or at least the last unique question that's been asked. Number 20, name the polygon below. Okay. Okay. Determine whether it is equiangular, equilateral, regular, irregular, or more than one of these. All right, so let's start at the beginning. We said it was quadrilateral, right? Good. All right, what else? You think it's regular? Equiangular? Okay, what else? Irregular? Yeah, it is irregular. Let's see. Yeah, I think we'd have to say it is because it's not regular. Do you know why it's not regular? Because it's not. I'm not told it's equilateral. How would I know? What would I have to have in order to see that it's equilateral? I'd have to have tick marks. All right. What else do I know this is? I can't say it's a square because it's not regular. It's a rectangle because a polygon with 4 right angles is a rectangle. What else? It's a polygon, right? We're going to overclassify here, which is fine. I think we can probably be done at this point. I want to see what their answer is on this because we might have gone further. We might have gone further than they did to answer this, which is not a bad thing. Quadrilateral, equiangular, irregular. But we overdid it, but that's fine. Okay, so what I want to do at this point, I want you guys to pay really, really close attention. Okay? I'm holding the test in my hand. Okay? I'm going to tell you what things are covered on the test. Okay, now some of these, almost all of these things should have been covered in the review. Some of them might have been, some of them maybe not as much. Okay? I can tell you that you're going to get a graph. On that graph is going to be a slanted line with 2 endpoints with it's not, well, yeah, it's going to tell you what the coordinates are, and it's going to ask you for the midpoint. So you need to know the midpoint formula given 2 coordinates. Okay? Next, and I deal with this in the previous video, you're going to be given an endpoint, and you're going to be given a midpoint, and you're going to have to find out what the other endpoint is. Okay? We have worked a question like that before. All right? If I was to tell you to go back and watch a video to find that question that we worked out, it would be in the lesson 11 video. I'm fairly certain. Okay? So that's something to check out. I can tell you that you're going to need to know basically everything I've told you from lesson 12. Okay? Those alternate interior, alternate exterior, corresponding, and same side interior angles. And you're going to have to be able to, basically, you're going to be given angles that are algebraic. So something like an angle is 6x plus 8 degrees, but it's going to tell you what to plug in for x. All right, and it's going to give you another one and say maybe it's something like 8x minus 12, but you're going to plug in that same value for x, and you're trying to prove that these 2 lines are parallel to each other. Okay, so you're going to check it, you're going to plug in x and see if the two angles are congruent, and then what theorem proves that the two lines are parallel. Do you follow me? Okay, I'm not writing this stuff down. You just have to listen to this part. Okay, you're going to show a triangle. You're going to have to classify it by its angles and its sides. Okay, angles and sides. You're going to be given an algebraic conjecture. You're going to have to pick the correct counterexample. Okay, remember, it has to be true to the hypothesis, but does not match the conclusion. Okay, you're going to be shown two congruent polygons. One of them is going to have a missing side measure. You're going to have to figure out what that missing side measure is. Should be maybe the easiest question on the test. Nobody in either class should miss that question. Let's see. You're going to have to be able to find the midpoint of a point on a number line. Okay? Can we do that? Do we know how to find the midpoint on a number line? We can do midpoint on a coordinate plane. Can you do midpoint on a number line? All right, again, if I was to tell you to go back and watch a video, right, or do something along those lines, I would say go back and watch lesson 11, okay? You're going to be shown a diagram of two lines cut by a transversal. It's going to ask you a question which says, which pair of angles, if congruent, proves that lines A and B are parallel? Remember, if two angles share a common vertex, they can't prove that two lines are parallel. They can't be right next to each other. Okay? And again, you're going to have to remember alternate interior, alternate exterior, corresponding same side interior, all those types of things. That diagram is going to be used for more than one question. It's going to be used for another question that's going to say, you know, if these lines are parallel and a certain angle measures a certain degree, what does another angle equal? Okay? Does that make sense? You're not going to be given a picture on this question, but you're going to be given a triangle. It's going to tell you what its base is, it's going to tell you what its height is, and it's going to ask you to find the area. Okay? If this question is on the test, I'm going to remove it because it's one that I skipped over when we were covering it because it's a time killer. I want to see if it's on here though. It is, and I'm going to have to take it off. So this test will be out of 19. Again, you're going to be given another counterexample, algebraic question. You're going to have to be able to identify if something is equiangular or equilateral based upon a statement. What do we know about vertical angles? Ooh, that's a bad sign because you're going to have to know something very specific about vertical angles to set up an equation to not only solve for x, but after you've solved for x, to plug it back in. You've had a question like this, I believe, on your last test. So if you don't know anything about vertical angles, at least not well enough to answer that question, then you need to look up lesson 6, it looks like. Lesson 6. You need to be able to find a distance between two coordinate points. So you need to know the distance formula. You should, and this is like a lesson 1 question, be able to identify a plane from a diagram. You're going to be given an angle and an angle bisector. And you're going to have to find a missing angle measure. This, again, is a question type that you've had before. Let's see. It looks like question 18. It won't be 18 on your test once I remove that other. But lesson 7. You want to go back and maybe watch lesson 7. You were given an equation, and you had to make a table of values and find a pattern, and then find a counterexample to that pattern. Okay? You're going to be given a triangle, a right triangle with one leg and the hypotenuse. You're going to have to find the missing side length, so you're going to have to use the Pythagorean theorem to find a missing side, not the missing hypotenuse, but the missing side. And you're going to have to write a conditional statement from a statement. So you have to make a correct if-then statement based upon one line of information. Does that make sense? Okay, that's what the test is going to cover. Okay? And if I forget to take off a particular question, I will just not mark it against anybody on test day. So if you see a question that I didn't talk about and it completely blows your mind, it might be the question. Did I take off? It may not be. All right, so I'm going to close this thing off right here. My suggestion to you is that you watch the first video. I think that's already been sent to you, okay? And spend some time watching that. And you might want to review some of the things that I've just said.